Hello students, this is Mr. Yang. In this lesson, we are going to talk about 5.1b, where we will continue to learn more trig functions and something else called cofunctions. So first, let's have a look. Trigonometric ratios continued. In this lesson, we'll continue to learn about the other trig ratios, and there are three more. We have learned last time about SO, which is the sine, that equals to opposite over hypotenuse. We have also learned the co, which is cosine equals adjacent over hypotenuse, and the TOA, which is tangent equals opposite over adjacent. Today, the three new functions that we will learn are called cosecant, secant, and cotangent. Cosecant, well, we can't exactly write the whole thing, and we also can't use COS anymore, so it's actually CSC, cosecant. And secant, we can still use the first three letters, so it's just SEC. And then cotangent, we can still use the first three letters, it is COT. Now, cosecant is hypotenuse over opposite, and secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. That's how they are defined. And now, if you haven't noticed, there's a reason why I write the cosecant under sine and secant under cosine and cotangent under tangent. Sine is opposite over hypotenuse. Well, that is O over H. But if you notice, cosecant happens to be H over O. And cosine is adjacent over hypotenuse, A over H, and secant happens to be H over A. Tangent is O over A, and cotangent happens to be A over O. So basically, cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. That would actually be very helpful for you to kind of remember how they work. All you still need to do is just find the sine, cosine, and tangent, then flip them to find the cosecant, secant, and cotangent. Here's something else that may help. As you can see, the sine is connected with the cosecant. So an S is connected with a C. And then an S for the secant is connected with the C for the cosine again. So basically what I'm saying is sine is not going with secant. There is no pair of them that actually start with the same letter. S and C are together, C and S are together, T and C are together. They're not going to have the same initial. Now let's move on to see how we can work with the triangles to find these new ratios. Find the exact value of the trig ratios. All three sides are given, and this is the angle that we need. So let's identify the opposite, adjacent, and hypotenuse first. This is the opposite because it's facing the angle theta. And 4, of course, is going to be the adjacent, is next to the theta. The hypotenuse is along its side, which is also facing the right angle. That is the hypotenuse. Sine is so opposite over hypotenuse, so 3 over 5. Cosine is co A over H, so it's got to be 4 over 5. And tangent is O, so O over A is going to be 3 over 4. And cosecant is just flipping the sine, so it's got to be 5 over 3. Secant is just flipping the cosine, so it's got to be 5 over 4. And cotangent is flipping the tangent, so it's got to be 4 over 3. That is example 1. You can pause here to practice on example 2. Now that you have some time, let's have a look. Theta facing 8. That means 8 is the opposite. And 8 is the opposite. Not opposite equal opposite. And 15 is next to theta, so 15 is the adjacent. Hypotenuse is facing the right angle, which is 17. Sine is again O, so O over so is O over H, so it's got to be 8 over 15. Cosine is co A over H, so 15 over 17. It's actually 8 over 17. And then tangent is O, so it's got to be 8 over 15. Now let's just flip all the fractions to find a cosecant, secant, and cotangent. 17 over 8, 17 over 15, and 15 over 8. That is example 2. Example 3 and 4. This time there's one side that is not given. So first, I know that is the opposite, which is 9. And hypotenuse is facing the right angle, so 13. Adjacent is the one that we don't know, we can use Pythagorean theorem to solve it. 9 squared plus x squared equals 13 squared. So that is 81 plus x squared equals 169. So I would know x squared is 88. Square root both sides. My x would simplify to be 2 square root of 22. That would have to be my adjacent side. For sine, opposite over hypotenuse, it is 9 over 13. Cosine, adjacent over hypotenuse, is going to be 2 square root of 22 over 13. Tangent, opposite over adjacent, it is 9 over 2 square root of 22. But remember, we can't have a radical in the bottom of the fraction, so we're going to need to multiply everything, multiply the top and the bottom by square root of 22, so we can get rid of the square root of 22 on the bottom of the fraction. These two becomes 22. Then we still have a 2 times the 22 is a 44 on the bottom. Top is 9 square root of 22. Cosecant, just flip everything. We will have 13 over 9 for sine. For cosine, it's 13 over 2 square root of 22. Same idea, multiply the top and the bottom by square root of 22. So we have 13 square root of 22 over 44. As for the cotangent, flip the tangent, that's going to be 2 square root of 22 over 9. That is example 3. Now example 4. 7 and 8 are given. That is facing the theta, so that is the opposite, 8. Adjacent is the one next to theta, so that is 7. We do need to find the hypotenuse. So 7 squared plus 8 squared equals x squared. That is 49 plus 64 equals x squared. So x squared is going to be 113. There's nothing we can do when we square root it, so it's just going to remain a radical square root of 113. Sine is opposite over hypotenuse, so 8 over square root of 113. We need to simplify it by multiplying the top and the bottom by square root of 113. That is going to give us 8 square root of 113 over 113. For cosecant, we just flip it, so square root of 113 over 8. For cosine, adjacent over hypotenuse, that is 7 over square root of 113, and it works the same way as the sine, which is going to give us 7 square root of 113 over 113. Secant, flip it, so square root of 113 over 7. Now the tangent, opposite over adjacent, is going to be 8 over 7. Cotangent, of course, flip it, 7 over 8. That is example 4. Next, if you had compared the answers of all the ratios on the left side and the right side of each question, you may have noticed, which is something I have already explained, that they are actually reciprocals. Cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Again, look at the initials. There are no same letters being paired with each other. So the cosecant goes with sine, the secant goes with cosine. Now let's actually use this property to help us find some values on our calculator. Now, for these, use your calculator to find each value, round to the thousandth place. For A, cotangent, 72 degrees. As you can see on your calculator, you only have sine, cosine, and tangent. So of course, that means when you want to find these, you are going to need to rewrite them into the one that work with the reciprocal one first. So cotangent is paired up with tangent. That means this is the same as 1 over tangent 72 degrees. Something to remind you, whenever you type these in your calculator, make sure you always check the mode first. Make sure your mode is on degree, not radian. And after you type it in, you should get the answer as 0.325 for this. And next, let's do cosecant. Cosecant, again, C doesn't go with the same letter, so it's not cosine, it's got to be sine. This is the same as 1 over sine of 90 degrees, which if you type in your calculator, it is going to still give you a 1. Next, secant 48 degrees, so S is going to pair up with the cosine, 1 over cosine of 48 degrees. Let's type in your calculator. That should give you 1.494. D, same idea. It's got to be 1 over tangent 120 degrees. If you type in your calculator, that should give you a negative 0.577. Next, it's secant 30 degrees. So that again is going to not pair up with another s, so it's got to be paired up with a cosine. That is 1 over cosine 30 degrees, which is going to be 1.155. Last one, cosecant. C is going to pair up with the s, so it's got to be 1 over sine 3 degrees. That is going to be 19.107. So these are how we're going to do the other 3 trig ratios with our calculator. Now let's move on to the last part. Well, before that, we need to actually set up triangles so we can find these trig ratios. Draw and label a triangle using the ratio given, then find the requested values. Cosine theta equals to 8 over 9. Again, cosine is cos, so it's got to be A over H. We can draw our triangle. You can draw a triangle however you want. Let's say this is our theta. Adjacent is 8, which means it's next to theta, and hypotenuse is going to be 9. We do need to find the third side since we're being asked for quite a few ratios. That's going to involve the opposite side as well. So my opposite is actually going to be, you can use Pythagorean theorem to solve it. This squared is 81, this squared is 64. The difference is 17, so it's got to be square root of 17 as my opposite. Cosecant, remember, is 1 over sine. So sine is O over H, then this has to be H over O. It is going to be 9 over square root of 17, which symbolizes to be 9 square root of 17 over 17. Secant is 1 over cosine. Since cosine is adjacent over hypotenuse A over H, this has got to be H over 8. My H is 9 and my A is 8. Cotangent is 1 over tangent, so it's not going to be O, it's OW, so it's got to be A over O. Then is going to be 8 over square root of 17, which symbolizes to be 8 square root of 17 over 17. That is example 6. Next, example 7. This time we are given tangent, which is O over A. So let's draw it out. If I have, let's see, if I have this as my theta, my opposite side, oh, that actually doesn't quite look like it. Let's say this is my theta, the opposite side is 24, the adjacent side is 7, and that squared is going to be 576, because we do need to find the hypotenuse for the ratios. That squared is 576, this squared is 49. Together it is 625, so this would have to be, my hypotenuse is 25. Secant is 1 over sine, so it's going to be, 1 over cosine, so it's going to be hypotenuse over adjacent. It is 25 over 7. Cosecant is 1 over sine, so it's got to be hypotenuse over opposite, so 25 over 24. Cotangent is 1 over tangent, so it's going to be A over A, which is going to be 7 over 24. And that is example 6 and 7. Lastly, we are going to talk about something called cofunction. But in order to talk about it, let's have a look at example 1 again with different angles. So we have theta 1 and theta 2. My theta 1 is right here. So with theta 1, this is my opposite for theta 1. And this is my adjacent for theta 1. That is my hypotenuse. However, well, let's actually write out sine theta 1 and cosine theta 1. So sine theta 1 is going to be opposite over hypotenuse, which is 4 over 5. And cosine theta 1 is going to be adjacent over hypotenuse, so it is going to be 3 over 5. Now let's actually change the angle. What if we now look at theta 2? Clearly, 4 is not the opposite of theta 2 anymore. With theta 2, my 3 is actually my opposite, and the 4 is actually my adjacent. though my hypotenuse doesn't change, I would still change my ratio for the sine and cosine. So sine theta 2 is actually 3 over 5, and cosine theta 2 is 4 over 5. And you can pause here to see if you notice anything about these sine and cosine ratios. Now that you have a look, maybe you have noticed the cosine theta 1 and the sine theta 2 have the exact same value, and then the other two have the same value. Not only do they have not the same trig ratio, they also not have the same angle. But there is a relationship between the angles, theta 1 and theta 2. Inside this triangle, if this is 90 degrees, that means my theta 1 and my theta 2 and the 90 degree together would make up 180. So that means get rid of the 90. Theta 1 and theta 2 would actually make up 90 degrees. And that is something that we have learned before, which is called complementary angle. So now here's what cosine actually means. You can see inside the word cosine, we have the word sine. So clearly this co means something. The co actually means complementary. So cosine actually means complementary sine. And complementary angle is a 90 degree angle. So these two angles actually form a 90 degree. That means if you look at all the names, sine and cosine, secant and cosecant, tangent and cotangent, they actually all have their own cofunction. And that means the 90 degree rule would apply. So here's how the identity is, how the cofunction identity is. Sine theta 1 would equal to cosine theta 2, which in other words, sine theta 1 actually equals to cosine of 90 degree minus the same angle. Cosine theta 1 is the same as sine theta 2, so in other words, cosine theta 1 is actually the same as sine of 90 minus the same angle. So it's always going to be changing the function using the cofunction that equals to the 90 minus the same angle. And that actually equals to the complementary angle of the given angle. Now let's have a look at the example. Example 8. Sine 30 degree is 0.5. If we want cosine to also be 0.5, we would need the complementary angle of 30 degrees, which is 60 degrees. Next, if we are trying to find cosine 0, it's actually a 1, and we want the sine to have the exact same value, then we need the complementary of 0 degree, so 90 degrees. Secant and cosecant are cofunctions, so if we want the same number, we are going to need the complementary angle of 23 degrees, which is 67 degrees. Cosecant 75 degrees, let's actually find out what that is first. Cosecant 75 is 1 over sine 75 degrees. That's basically what we just learned, and that, if we round, is going to be 1.035. If we want a secant to have the exact same value, we need the complementary angle for 75 degrees, which is 25 degrees. If tangent 50 degree is 0.766, and we want cotangent to be the same number, we're going to need the cofunction for 50 degrees, which is 40 degrees. And lastly, cotangent, well, we just learned how to find that in our calculator, is going to be 1 over tangent of 32 degrees. That will give us 88.210. And we want a tangent to have the same value. That is going to be the the complementary angle, which is not 64, which is actually 54 degrees. And that is everything for 5.1b. Thank you.